gonna make the fixture for the Titan 513M. So we're actually using the same setup that we used in the previous operations. The reason why we did that is for efficiency. We can quickly reset up our fixture, and we're also holding it in a free state. If you want to see how I did that, go ahead and check out the previous videos. I'll show you how to do it step by step. Next, I'm going to cut the fixture. We're going to hold the top surface nice and flat, so that way when I cut my 4 counterbores into my fixture and install my shunt clamping pins, I'm then going to flip my fixture over and place it into my shunt quick change pallet system. So that way when we set this job up every other month, we have incredible repeatability, and all we have to do is indicate the side and the back of our fixture and we're good to go. Now all I have to do is cut my part.
We're going to go in and cut out these 4 features for our shunt clamping pins. We're going to come in and face the top of the part. Tool 1 is a 3-inch Kennametal face mill, a SFM of 3,109. My spindle speed is 4,000. My feed rate is 30 inches per minute, and my feed per tooth is 1 thou 9/10. My plunge rate is 100 inches per minute. In our cut parameters, we have a step over of 2.2 or 75% of the tool. We have our overlap set to 25, our long overlap set to 110, so the shell mill comes completely off of our part. Our approach distance is 15%, same thing with our exit. Our max step over is going to be 75%, so that way we get a nice full contact with our face mill. The 2 important things on this page is that we have our style set to 1 way. This will ensure that our face mill starts on one side and goes to the other, then retracts and repeats. The next important thing is that we have our roughing angle set to 180. This will ensure that our tool will come down and start on the opposite side of our stops. That, in combined with the low, careful feed rate, will allow us to lightly clamp the part. Since the part is very lightly clamped, we don't want it to slide out or move while we're machining it. So we have our tool start on the opposite side, so that way when it's cutting, the load and force will be properly pushed into our stops, which is on our left side. This will allow us to carefully machine the flatness with our part in its free state, while also allowing us to use the tool's force to our own advantage. These 2 things combined will give us a perfect flatness while allowing us to lightly clamp it. The next tool path is we have to rough out these 4 counterbores. To do that, I'm going to be using a 2D high-speed dynamic tool path. The tool that I'm going to be using is T2, which is going to be our 3/8 3-flute end mill. I have a SFM of 796. My spindle speed is 8,112. My feed rate is 60, and my feed per tooth is 2 thou 5/10. My plunge rate is 100 inches per minute. In my cut parameters, my step over is 15%. Since we're lightly holding onto this part, I don't want it to move too much. My stock to leave, I have 5 thousandths on the wall and 5 thousandths on the floor. Now that these pockets are roughed, we're going to come back and finish them. My SFM is set to 392. My spindle speed is at 4,000 RPM. My feed rate is 15 inches per minute, and my feed per tooth is 1 thou 3/10. My plunge rate is 100 inches per minute. For our next tool path, we're going to drill out the minor of our thread inserts. The tool that we used is T3, which is our 7/16 Go drill. We have a SFM of 1013 with a spindle speed of 880. We are going with a feed rate of 88 inches per minute with a feed per tooth of 5 thousandths. For my cut parameters, we're going to be using a G81 drilling cycle. No pause. For our linking parameters, we have a clearance height of 250. Our retract and top of stock planes are both negative 100 thousandths. Our depth is simply the bottom of our hole. Our next tool path, we are going to chamfer. To do that, I'm going to be using a 2D drilling operation. The tool that I'm going to use is T5, which is our 5/8 90-degree dual lock chamfer mill. My SFM is set to 490. My spindle speed is 3,000. My feed rate is 20 inches per minute, and my feed per tooth is 3 thousandths 3/10. For my cut parameters, I'm going to be using a G81 with no dwell. For our linking parameters, we have a clearance plane of 250. My retract and top of stock are both a negative 100 thousandths. For my depth, I have a pre-calculated number of our pocket plus our chamfer size. This gives us a negative value of 0.45185. Now that we have our threads chamfered, our next tool path, we are going to chamfer our pockets. I have a SFM of 1,636. My spindle speed is 10,000 RPM. My feed rate is 100 inches per minute, and my feed per tooth is 5 thou. My plunge rate is 100 inches per minute. My cut parameters, I have a 20 thousandths chamfer with a 50 thousandths offset, which will drop the bottom of the tool 50 thousandths under my selected contour. Make sure that my linking parameters are set with a 250 retract height. My feed plane is simply 100 thousandths. Top of stock is 0. My depth is 0 since I have my chamfer already pre-calculated into my cut parameters. Next, we can tap these holes using a 2D tapping cycle. We'll be using a 2D tapping cycle. The tool that I'm using to do this is T4. My SFM is 28. My spindle speed is 221. I have a feed rate of 17 inches per minute. My feed per tooth is 0.0769. For my cut parameters, I'm going to be using a G84 tapping cycle. For my linking parameters, I have a clearance plane of 0.25. My retract and top of stock are both negative 100 thousandths. For my depth, I have a value of the bottom of our thread, which has already been calculated in. This is all the parameters needed to tap the 4 holes and give us our 1/2-13 thread for our thread insert.
So we just got done with the first op on the Titan 513M fixture. I've gone ahead and engraved the X0, Y0 up in the top corner. Checked it with my go, no-go pins. It's come out perfect. I've already checked the bore diameter and the depth of the counterbore. They've come out perfect. So now all I need to do is give it to Travis He'll go ahead and sign off on it, and we'll be ready to do our next operation on the DMG Mori DMU 50.